Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 42 for October-November 2024, and this is part 1 for questions 1 to 4. Question 1 is coming from Kinematics. They're saying the velocity of a particle moving in a straight line at time t seconds after leaving a fixed point O is v meters per second. The diagram shows the velocity time graph which models the motion of the particle from t is equal to 0 to t is equal to capital T. The graph consists of four straight line segments. The particle accelerates from rest to a speed of v meters per second over a period of 4 seconds, and then decelerates at 5/3 meters per second squared to instantaneous rest over a period of 6 seconds. The particle then travels back towards O, reaching a maximum speed of 3. Before coming to rest at t is equal to t. Now, they want us to find the value of v. So we can use deceleration. You should know that deceleration is actually negative acceleration, okay? Let me write it here. Deceleration is equal to negative acceleration. Negative acceleration. Now that means that if A is equal to v minus u over t, then that means that for this case the deceleration is negative. Now we are given 5/3, then we are going to equate it to 0, because now that is the final. It begins from here, so this will be the initial, and then this will be the final, okay? So we are going to have our final here as 0, then minus, because here on t-axis v is 0 here, okay? So 0 minus, then the v we are looking for over the time taken is 6, 10 minus the 4. And then now we make v the subject. Of course, the minus is going to cancel, so we shall have 5/3 times 6 will give us the v. 3 goes in here 2 times, so that means v is going to be equal to 10 meters per second. That is that. Then part B, given that the total distance traveled by the particle from t is equal to 0 to t is equal to capital T is 68 meters. Find the value of t. Now, we should know that on a velocity time graph, total distance is equal to total area under the graph. Total area under the graph. And do you know where this one comes about? Now suppose, let me even use this diagram here that they have given me here. We know that speed, distance, and time are connected in this triangle, okay? Now you can see that here we are having time, okay, and here we are having the speed. So if I say speed times time, here distance is equal to speed times time. You see that? So if I want to find the area of this triangle here, I'm going to get a half the area of this rectangle, not so? So I'm going to say a half times 4, then times the v there. Now, having gotten t, then times the speed here, which is here, s times t, then it gives us the distance. So that's why area under the graph gives us the area under the graph for a speed time graph. It gives us the distance traveled. So now let's look at the distance. The distance is given as 68. So I'll write 68 here. And then the first one here is a triangle whose base is 10. And then height is the v we have gotten, which is also 10. Okay. So we just substitute here. So 68 then is equivalent to a half times the base is 10 times also the height is 10. And then plus, we also have this other one here. This one, the base is going to be t minus 10, and then the height is going to be this 3. Okay, lengths are not negative, so we shall take it as 3, not negative 3. Okay, so we shall have the base as t minus 10. So it is also a triangle. So a half times the base, which is t minus 10, then times the height, which is 3. Okay, don't write -3. Length cannot be a negative. Okay, then after that, this is 68, which is equal to 100 divided by 2, that is 50. And then here we have 3, sorry. Then here we have plus now 3 over 2 into t minus 10. I can take 50 this side, then I get 68. When I subtract 50, it will give me 18. Then 3 over 2, then t minus 10. Then I will cross multiply. This one will give me 36. Then I will divide by 3, right? To get t minus 10. Now this one will give me 12. Now 12 plus the 10, then it will give me the t. So that means t is equal to 22. Question 2. A block of mass 20 kilograms is held at rest at the top of a plane inclined at 30 degrees to the horizontal. The block is projected with speed 5 meters per second down a line of greatest slope of the plane. There is a resistance force acting on the block. As the block moves 2 meters down the plane from its point of projection, the work done against resistance is 50 joules. And then they're saying find the speed of the block when it has moved 2 meters down the plane. There are 2 methods I can use here. The energy method and also the other one of forces, okay? When I use the one of forces for F is equal to ma, then later I can find the speed. If I've gotten the acceleration, then I can substitute in the equations of motion to get the speed. So we are beginning from here. Let's say that our particle is here. Now, since there is this vertical height here, okay, there is an angle here which is 30 degrees. Now, at this position, there is potential energy because there is vertical height, which we have to find, okay? Then there is also kinetic energy because this particle is projected with a speed which is 5 meters per second, okay? And then it moves down this lane, which is 2 meters long. And then by the time it reaches here, there is kinetic energy because it is moving with a certain speed, which speed we are looking for. Okay, all the potential energy has gone because now we are on the level ground. Okay, there is no vertical height. Using SOHCAHTOA, sine of 30, I want to find this vertical height. So sine of 30 is equal to opposite, which is h over hypotenuse 2. When I cross multiply, h is going to be 2 sine of 30. But sine of 30 is a half. So that means a half of 2 will be 1. You see that? So our h here is equivalent to 1. Then, after that, I can now use the work energy principle. Okay? Using the work energy principle, which states that work done by the driving force, work done by the driving force minus work done against resistance, work done against resistance, then is equal to the change in mechanical energy. Change in mechanical energy. And mechanical energy is the sum of kinetic energy and potential energy. Kinetic energy is a half mv squared. Potential energy is mgh, where h is the vertical height. Now, since this particle is just projected from here to go down, okay, there is no force that is taking it down. The driving force is that force which is applied onto this particle and it goes with it until it comes, okay, down here. So it is not there. That means work done against, I mean by the driving force is 0. Then they told us that the work done against resistance is 50 joules. So that means I'm going to put here 50. And then I come to this other side. Change in mechanical energy, I get final mechanical energy. So final is here when we have only kinetic energy. Then initial is here where it is starting from. So I will have the final kinetic energy is going to be a half m. M is 20, and then v squared. We need this speed, then minus. Now the initial mechanical energy is going to be sum of the kinetic energy. So a half times 20, then times the speed it was projected with, which is 5. So 5 squared. Okay, then plus mgh, that is 20 times 10, then times our h, which is 1. Okay, we have gotten it up there. Now we make v the subject of the formula. We can simplify. Here we have 50, which is equal to, here we shall have 10 v squared. Then inside here we are having 10 times 25, that is 250, and then plus 200. So this one gives us 450. Then I bring it this side, it becomes a positive. So 450 minus 50 then is equal to 10v squared. So meaning we have 400 here, then we shall divide it by 10, okay? And then after we square root that to get v. So that means v is going to be equal to the square root of 40. You can leave it like that, or you can put it in 3 significant figures, which can be 6.32. Okay, next, I can use an alternative method, the one of forces. Okay, alternatively, we can do this. So I have this diagram of mine here. This particle here, there is this weight here acting downwards. Then remember it came from here. So this angle theta, which is 30. So here we have mg cosine of theta. And then here we have the normal reaction r. Then here, when we resolve mg here, it will be mg sine theta. That's sine 30, okay? Now, that is our theta there, which is 30. And then this way we shall have the resistance, okay? Resistance to motion. Now, we have F, which is equal to MA, all right? So we have this mg sine theta minus the resistance force, okay? That will be the net force that takes the particle down. However, since we have the work done against resistance, and work done is force times the distance, so the force here is the r. The distance moved is 2. This is 2 meters, okay? Then the work done is 50. That means the resistance force is going to be equal to 50 divided by 2, which is 25 newtons. So, in fact, I can put ES so that it is different from this normal reaction here. Okay, now we are going to have this mg. M is mg sine theta. Mg sine theta minus the resistance force. Then this one is equal to MA. Okay, so what is mg? M is 20, g is 10, then sine of 30, then minus the resistance force, which is 25, then is equal to 20 A. So that means A is going to be, sine of 30 is a half of 200, that is 100. Okay, so we have 100 minus 25, which is 75, then divide by 20. That means A is going to be equal to 3.75 meters per second squared. After getting the acceleration, then I can use v squared is equal to u squared plus 2as. Now, v is going to be there for the square root. Since this one was projected with a speed of 5, then that is the initial 5 squared, then plus 2 times the a, which is 3.75, times the distance traveled is this 2 meters here. So times 2. And then here we shall have 25 here, then plus 4 times 3.75, That one gives us 15. So 15 added to 25, you can see that we get a 40. So RV is root of 40. So either way, you get the answer. Question 3. A cyclist is riding along a straight horizontal road. The total mass of the cyclist and his bicycle is 90 kilograms. The power exerted by the cyclist is 250 watts. At an instant when the cyclist's speed is 5 meters per second, his acceleration is 0.1 meters per second squared. Part A, find the value of the constant resistance to motion acting on the cyclist. Like I've always said, you must master the art of drawing diagrams, and then you put the forces that are acting on the particle. Okay, it will help you in attempting this question. So this is my car, and then I have the driving force taking it forward, then the resistance force which acts in the opposite direction. Now we know that power is equal to force times the speed. Why is it force times the speed? Power is the rate of doing work. In other words, it is work over the time taken. So work is force times distance, then we divide by the time, but distance over time is speed. That's why we have FV. See that? Okay. Now, we have power, which is equal to the driving force times the speed or the velocity. That means our driving force is going to be equal to power, which is 250, divided by the speed, which is 5. Okay, they gave us the speed here. So meaning this one is giving us 50 newtons. Okay, so the driving force is that. Now using F is equal to MA. So our driving force here is, the net force that takes the particle forward. You get the driving force minus the resistance force, then is equal to the MA. Okay, so the driving force, we have gotten it as 50, then minus now the R, and then the mass of the cyclist and the bicycle is 90, times the acceleration, which is given as 0.1. So meaning we can have 50. If I take this one this side, then it is going to be a positive. So bring the 90 times the 0.1, and I think that one will give us a 9. Then is equal to R. So that means our constant resistance is 41 newtons. Like that. Okay. Then next they are saying the cyclist comes to the bottom of the hill inclined at 2 degrees to the horizontal. Part B. Given that the power and the resistance to motion are unchanged, find the steady speed. Steady speed is the same as constant speed. And for this case, acceleration is 0. Okay. Find the steady speed which the cyclist could maintain when riding up the hill. I can put my sketch here. Okay. When riding up the hill. So the cyclist is maybe here and is riding maybe up to there. Okay. This cyclist has reached here, but there is a resistance to motion which we have found as 41 newtons. But also it has mg sine theta. There is always mg sine theta acting downwards on an inclined plane, which is the horizontal component of the weight. Okay. All right. Now using F, which is equal to MA. Okay. Our driving force here. So we have the driving force taking the cyclist up. So driving force, then minus 41 minus mg sine theta. When we are using the energy method, we don't use this mg sine theta. We just take the whole of it as the, in other words, it is this resistance due to motion, to friction. Okay. But when you use the F is equal to MA, that is when you consider the mg sine theta. But that mg actually sine theta is catered for in the energy method where we are using the potential energy. Okay. All right. Then next here, we are going to equate to 0 because acceleration is 0. So meaning the driving force is going to be equal to 41, then plus the mass is 90, I think. 90, then times 10, and then sine of the angle is now 2 degrees. So This one is 41 plus 900. First, leave it exact. You don't need to write the decimals here. Always round off at the end. So we have power is equal to the driving force times the speed, right? Or the velocity. And then here we shall have, right from here, the driving force is going to be equal to power divided by the speed, not so? So the power is 250 because they said it is unchanged. And then we divide by the speed, which we are looking for. Now, this one here is our driving force, the new driving force, okay? Then these two, we equate them. You see that? So we are going to have 250 over V, which is equal to 41, then plus 900 sine of 2. So meaning when I cross multiply here, the 250 will be divided by 41 plus 900 sine of 2. This one will give us the V. So then what is that V? You put everything in the calculator. So we have 250 divided by 41 plus 900 sine of 2. The calculator must be in degrees. Okay, so that is 3.45 to 3 significant figures. 3.45 meters per second to 3 significant figures, just like that. Question 4. The diagram shows two particles A and B of masses 0.2 kilograms and 0.1 kilogram, respectively. The particles are suspended below a horizontal ceiling by two strings AP and BQ, attached to fixed points P and Q on the ceiling. The particles are connected by a horizontal string AB. Angle APQ is equal to 45 degrees and BQP is equal to theta. Each string is light and inextensible. That means you cannot stretch it any further. It is light, meaning its mass is negligible. Then the particles are in equilibrium. Find the value of the tension in the string. So the value of the tension in the string, since this one is a string, then we are going to have tension, which is generated there. So I can actually say this is the tension in the string AP. And then also here I can have the tension in the string BQ. Then for each of these particles, since they are horizontal, they have gotten weight, which is acting directly downwards. So that is 0.1 g. You know weight is mg. Then this is 0.2 g. Okay. And then this being a horizontal line, I can extend it, okay? And then using the principle of angles on parallel lines, this angle 45 is equal to the one here, 45. So meaning this one here is 45. And also here, if I extend this one here, it simply implies that here we have theta. And then we resolve the forces. If you have been following me every now and then, you should know that when we are resolving the forces horizontally, when we are closing the angle, it is cosine. So we close this TBQ and it comes here, it will be facing here. That will be TBQ, then the cosine of theta. And then when we close this one here, it will be TPQ, T of AP, then cosine of 45. Then there is this one vertical. If this one is cosine, then the one up here has to be sine. So we shall have TAP, sine of 45. The same thing here. This one will be TBQ, sine of theta. Okay? And also, this same tension here in this string is going to be the same here. No, it's not the same. It's actually different. But there is tension in this string here. This tension actually pulls this A, this side. So I can say tension TAB. But it is the same tension also which pulls this B here, tension TAB. So that is our diagram of forces. Now, when we are finding values here, just look at forces acting on one particle. So forces on A, okay? Forces on A. look at A here. So vertically, resolving those forces, we have TAP sine of 45. Okay? Then this one is equal to the one going down here, the weight, so 0.2 G. You see that? So of course sine of 45 is the same as 1 over root 2. So we shall have TAP, the tension in AP, divided by root of 2, then shall be equal to 0.2 times 10, that is a 2. So meaning TAP is equal to 2 root of 2. Okay? Then I keep that one there. Then horizontally, again acting on A, we have TAB here equal to what is going this side. Remember, the forces are in equilibrium. So TAB is equal to TAP, then cos of 45. Now, we can now substitute TAB is equal to TAP. We have already gotten it as 2 root 3. And then cos of 45 is 1 over root 2. Don't you think this one cancels with this? And therefore your tension in AB is equal to 2 newtons. So that is that. Part B, find the value of theta and the tension in string BQ. Now here we shall look at forces acting on B. Okay, forces on B. So which forces do we see on B? Right from here, we can see that up here we have TBQ sine theta, and then down is 0.1 G. TBQ sine theta. So upwards, vertically, I will write TBQ sine of theta, which is equal to 0.1 G. So if I can simplify this one, we can have TBQ sine of theta, which is equal to 1, right? Then I can keep this one as my equation 1. Then horizontally, what is happening? Go back and check the diagram. So horizontally, we have TBQ cos theta, which is equal to TAB. TBQ cos theta is equivalent to TAB. Okay, already we got our TAB, the tension in the string AB, as 2. That is my second equation. Then I solve these two simultaneously. How can I solve them simultaneously? I can say equation 1 divided by equation 2, such that I can put the sine and cosine in one thing, tan. Okay, so I can have TBQ sine of theta divided by TBQ cosine of theta, which is equal to 1 over 2. So you can see that TBQ goes, and this becomes tan of theta, which is a half. Meaning, if I want theta, then it is going to be the arctan of a half. And putting that in the calculator, the arctan of 0.5, that one will give us 26.6 to 1 decimal place. So theta is equal to 26.6 degrees to 1 decimal place. If it is in degrees, always indicate that it is in degrees. If you don't put anything here, then they assume that it is in radians. Okay, so that is very important. Okay, then we need to get TBQ. They say find the value of theta and the tension in a string BQ. So TBQ, we can substitute in any of them, whether TBQ sine theta is equal to 1 or this one here, whichever you want. They all give the same value. So using the first equation, TBQ is actually going to be 1 over sine of theta. So if I say 1 over sine, don't put this one here to 1 decimal place. It's better you just bring the whole of this, the arctan of the 0.5, okay, like that. And then you see what the calculator gives you. So TBQ is going to be equal to, I can I can leave it there, and then I say 1 divided by, then sine of that angle. You see? So this one can actually give us right away, just like that. And we get the answer as 2.24 to 3 significant figures. 2.24 newtons to 3 significant figures, just like that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.